right? So this is about your first chapter. Then second chapter will conducted by the Kushal sir. So I start with the third chapter, that is divide and conquer algorithms. Right? Now, first of all, understand what is divide and conquer algorithm, or what is divide and conquer algorithm strategy. Right? So in this strategy, right, the big problem is broken down into smaller sub problems, right? And solution to these sub problems is obtained, right? Then after getting the solution of this sub problem, right, this strategy combine all the sub problem solution together and at the end find the solution of the whole, right? So let us understand the general method, right, of divide and conquer, right? So okay, so this is the introduction of divide and conquer, right, which I already discussed, that many useful algorithms are recursive in structure, right? Now who will tell me what is recursiveness or what is recursive algorithm? Do you know what is recursive algorithm?
Calling itself.
Calling itself, right? So that is recursive algorithm. So many algorithms are recursive in structure, right? So to solve a given problem, they call themselves recursively, right? Many times a પોતાને જ a function પોતાને જ call કરશે. So that is recursive function, right? Now this algorithm are normally follow the divide and conquer strategy or divide and conquer approach, right? Now, as I already told you that divide and conquer approach follow the three steps. First step is divide, right? So એમાં શું થશે? It will break the problem into several sub problems, right? That are similar to the original problem but smaller in size, right? So એ શું કરશે? Suppose you have one problem, right? And you want to uh, design the algorithm for that particular problem using divide and conquer strategy, right? So first step is it will divide your problem into smaller sub problems, right? Second step is conquer, right? In conquer, it will solve all the sub problems recursively, right? Now, if the sub problem sizes are small enough, right? So it will directly solve the sub problems. If sub problem size are large, then again it will repeat the same procedure, dividing the sub problems into smaller sub problems, right? And after solving all the sub problems, third step is combine. That is, combine this solution of sub problems to create the original problem solution. Right? So all of you getting the general method of divide and conquer strategy?
Yes, ma'am.
Okay. So this is the time analysis for divide and conquer strategy, but Kushal sir not taught you the analysis part, right? So right now we just go through this analysis part. After completion of analysis of algorithm chapter, right, we understand this analysis part in detail. Okay, so right now just we go through this. Just wait. Okay, so this is the equation for master theorem, right, which is taught by the Kushal sir. Right now you just remember this thing, that uh, Let Gn be the time required by divide and conquer on instance of size n. Right? So total time Tn taken by the divide and conquer algorithm is given by this recurrence equation. Right? Recurrence equation is a part of your chapter number 2. Right? So this consider this is the recurrence equation for divide and conquer algorithm. Right? Now compare this algorithm with this master theorem algorithm. Right? And if you solve this algorithm, you will get the Tn value like this. Right? If L is less than B of K, Bk, if L is equals to B, K, and if L greater than B of K, then you will get this time complexity for divide and conquer algorithm. Right? We will understand this in detail after you complete your second chapter. Right? So in divide and conquer method, right? If you have problem of size n, right? So first step is divide that n size problem into number of subproblems. So first it will divide into two parts, right? So subproblem 1 of size n by 2 and subproblem of problem 2 of size n by 2, right? Now if that subproblem are smaller in size, right, then it will solve that sub problem. If that sub problem also a large in size, then again it will divide that sub problem into two part, right, and solve all the sub problems individually. After solving all the sub problems individually, it will combine the solution of all the sub problems and give you the final original solution of given problem, right? So there are some problems that can be solved using by the divide and conquer strategy. Right? There are various problems that we can solve using the divide and conquer strategy. Right? So first problem that we can solve with the use of divide and conquer strategy is binary search. Right? So binary search is one type of problem that we can solve using divide and conquer strategy. So right? Now, binary search is a well-known efficient searching method, right, which use instance of divide and conquer approach. Right? Now, while searching the element using the binary search method, right, most essential thing is that all the elements in array should be sorted one. Right? So take array T1 to n of increasing sorted order, that is T of I is always less or equals to T of j. Whenever 1 less or equals to I less or equals to j less or equals to n, it means T is your increasing sorted array. Right? So first element is always less than second element is always less than third element is always less than fourth element, like this. Right? Now let x be some number. Right? Here x is your key. Right? X is your key element, right, which you want to search. Right? So the problem consists of finding key value x in the array T if it is there. Right? So if you have one array of 10 numbers, right, and if you want to find some number from that array, so search number will be your key value, that is x. Right? And what is your binary search problem? Binary search problem is finding the key value from the array if the key value is there. Right? Now, if the key value x is not in the array, then we want to find the position where it might be inserted. Right? Now, if the requested key value which you want to search is not present in the given array, right? So we have to find the value of key element, then we can insert that element into that sorted array, right? So this is the introduction of binary search, right? So take array T is a sorted array, right? Then find the value of key X from that array, right? Now if that key is present, right, that will return the position of that key value. And if the key X is not present in the array, then we want to find the position at which position we can insert that element, right? So let us understand the binary search with the use of example, right? So input for binary search is one sorted array, right? And value of X is equals to 7. It means value of key is equals to 7. So problem is we have to find the 7 in this given sorted array, right? આપણે શું કરવાનું છે? આપણે 7 ફાઇન્ડ કરવાનું છે કયા એરેમાંથી જે આપણે આ એરે આપ્યો છે એમાં, right? So this is here our sorted array input, right? Now first step is find approximate midpoint, right? First step is give index to your array, right? Then next step is find the mid value, mid element of array, right? So find the mid element of array. There are total 9 elements in our array. So mid value at position 5, right? So this is our midpoint of this array, right? Now next is અહીંયા સુધી ખ્યાલ આવ્યો બધાને? ફર્સ્ટ શું કરવાનું છે? ફર્સ્ટ ગીવ ઇન્ડેક્સ ટુ યોર એરે, દેન ફાઇન્ડ ધી મિડ વેલ્યુ ઓફ યોર એરે. અહીંયા સુધી ખ્યાલ આવ્યો?
Yes, ma'am.
At least, okay. Now next is we have to search element 7 because our key value, that is X, is equals to 7, right? Now check if key value is equals to midpoint value or not, right? Now if your key value is equals to midpoint value, right, then desired element is present in the list, right? If your value of X is equals to midpoint value, then desired value or desired element is present in the list. But here key value is not equals to midpoint value, right? So then check that key value is less than midpoint value or key value is greater than midpoint value. Now our midpoint value is 11 and key value is 7. So key value is less than midpoint value or key value is greater than midpoint with key value is greater than midpoint value.
Less than
Give me
minimum.
answer. Less than midpoint value, right? So if your key value is less than midpoint value, right, then search in the left subtree. This is called the, if whenever you divide your array into two partition with the use of midpoint value, so previous element of midpoint value will become the left subtree or a left sub list, right? And after elements are known as right sublist, right? So if your key value is less than the midpoint value, then search in the left sublist, right? And if your key value is greater than the midpoint value, then search in the right sublist. Here our key value is less than midpoint value, so we have to search into left sublist, right? So is 7 is less than midpoint value? Yes. So find into area before midpoint. So area before midpoint is known as left sublist, right? Now again repeat the same procedure because we use the divide and conquer strategy, and divide and conquer strategy use the recursive method, right? So after find out that our key value is in left sublist, right? Again divide your left sublist into mid two partition, right? So first is find the approximate midpoint, right? Now here in left sub list we have total 4 elements, right? So second index will become your midpoint value, right? If you have 6 elements, then third index position will become your midpoint value, right? So here we have total 4 elements, so second index will become your midpoint value, right? So next is check that your key value is less than this midpoint value. Okay, sorry. Check the key value is equals to this midpoint value. No. Your key value is less than this midpoint value. No. The, your key value 7 is greater than your midpoint value. Yes. Right. So find out the key value into right sublist. Right. So we have to find out into this right sublist of this array. So we have to find into right sublist. Right. Now again divide your sub problem into two partition, right? So find the midpoint position. So our midpoint position is now become this, right? Now check our key value is equals to our midpoint value. Yes, right? So this will the end of your binary search divide and conquer algorithm because you get the key value, right? So you search the key value at position 3 in your array, right? So this is the binary search. So કરવાનું first give index to your array, right? Then find the midpoint value, right? After finding the midpoint value, divide your array into two partition, right? Now if this midpoint value is equals to your key value, no, then if mid check if midpoint value is less than the key point value, sorry, key value is less than the midpoint value. Yes, then find out into left sub list, right? So we divide our array into two partition, then left sub trimmer, find the again repeat the same procedure, find the midpoint value, right? Check that key value is equals to midpoint value. If it is not, then it is greater than or less than. Depending on it, you have to find into either left subtree, either right subtree. If it is less than, if key is less than the midpoint value, then search into left subtree. If key is greater than the midpoint value, then search into right subtree, like this. Right? Example માં ખબર પડી બધાને? Or if you have any doubt in example, at least say yes or no.
Yes, ma'am.
Okay. So next is, as our subject is algorithm analysis and design, right? So we have to design algorithm for each and every problem, right? So this is the binary search algorithm, right? This is the iterative algorithm. Then we can after this we write down the recursive algorithm also, right? So input for algorithm are one array, right? કે જેમાંથી આપણે સર્ચ કરવાનું છે and key value x, right? Now if key value x is greater than t and then return n plus 1. It means your key value is not present in the given array, right? Then set I is equals to 1, j is equals to n. Now while I less than j, right? So this loop is for tracing the array, right? Now find out the midpoint. So that is k is equals to I plus j divided by 2, right? First index plus last index divide by 2. So it will give you the midpoint value or mid value, right? Now check if your key value is less than the midpoint value, right? Then your j uh, then assign the value of k into j, right? So જે તમારું midpoint value જે હતી એ હવે શું થઈ જશે, તમારી k ની value થઈ જશે, right? Else I is equals to k plus 1 and return I. So let us understand this algorithm with the use of example, right? Here we have total 7 elements in our array. So n is equals to 7. USB right? Inserted. Value of array t is equals to 3, 6, 7, 11, 32, 33 and 53, right? Then value of I is equals to 1. So it will point this first element and j is equals to n. So it will point the last element of array. Value of k is equals to I plus j. Right? So 1 plus 2, that is 4. So k point to this fourth index element, right? Next, value of x is equals to 7. It means key is equals to 7, which we want to search in this given array, right? So check if 7 is less or equals to t of 4, that is 11. 7 is less or equals to 11. Yes, then k will become the j. So હવે આ જે j ની વેલ્યુ છે ક્યાં આવી જશે, k ની જગ્યાએ, રાઈટ? સો હવે આપણે સામાં સર્ચ કરવાનું છે આ ઉપરના સબ લિસ્ટમાં, રાઈટ? બીકોઝ k ની જે વેલ્યુ છે, સોરી કી ની જે વેલ્યુ છે એ આપણા મિડ પોઈન્ટ કરતા નાની છે. સો નો નીડ ટુ સર્ચ ધીસ પાર્ટ, right? We have to search into left sublist, right? Again, repeat the same procedure, right? Until we get the value of position where your x is equals to 7 is present, right? Now, if our value of x is equals to 33, right? So શું થશે? It will not execute this j is equals to k, right? Because this condition is false, right? Because value of x is greater than t of k, because t of k is 11 and x is equals to 33. So value of x is greater than t of k. So it will execute this else part. Else I is equals to k plus 1, right? So this will become our I and j, because our key value is greater than our midpoint value. So we have to search into right sublist, right? And we repeat the same procedure until we get the midpoint, key value, right? So this is the iteration algorithm. Now let us understand the recursive algorithm, right? Same function binary search. Inputs are array and key value, right? Now if n is equals to 0 or x is less than tn, then return n plus 1. If there are no elements in your array and if the requested key value is not present in the array, then return n plus 1. Else return binary recursive t1 to n or x, right? So this is the function for recursive binary search, right? Now, if I is equals to j, then return I. It means whenever you get the value of I is equals to j, it means you find the position for requested key element, then return the value of I, return the position of that particular element. Right? Now, first find the midpoint value. So that is k is equals to I plus j divided by 2. Right? Then check the condition. If key value is less than the midpoint value, then call this function. Right? Again, right? After calling this function, it will again find the midpoint value, right? And check the value is less than midpoint value, then again divide the problem into sub problem. If value is greater than midpoint value, then it will return the recursive problem but with value k plus 1 comma g, right? So it will replace the value of I with k plus 1 and value of k with g, right? So let us understand binary search analysis, right? So again, for this you require the master theorem explanation, right? So just right now we go through it, then we will understand it in detail after you complete your second chapter, right? So recurrence equation for this binary search is Tn is equals to Tn by 2 plus theta n, right? Now here Tn by 2 is the time required to compare left sublist or right sublist, right? Tn by 2 is the time required to compare left sublist or right sublist plus theta 1, that is for one comparison made with middle element, because middle element આપણે સાથે આપણે check કરીએ છીએ, right? If key value is equals to middle element, then time required to search the element is theta 1, right? Now, if middle element is not equals to key element, then we have to search into either right sublist or either left sublist. To search into either right sublist or either in left sublist, time required is t divided by t n divided by 2, right? Now compare this equation with the master theorem equation, right? So A is equals to 1, right? B is equals to 2 and Fn is equals to theta 1, right? So for that we get Tn is theta log n. આ theta log n કેવી રીતે આવ્યું એ તમને સર શીખવશે, રાઈટ? પછી આપણે આપણા અલ્ગોરિધમ સાથે કમ્પેર કરીને જોશું. રાઈટ, જેટલા પણ ડિવાઇડ એન્ડ કોન્કર સ્ટ્રેટેજી, જેટલા પણ અલ્ગોરિધમ આપણે કરશું ઇન ધીસ સબ્જેક્ટ, રાઈટ, બધાનો એનાલિસિસ પાર્ટ આવશે. પણ એનાલિસિસ કેવી રીતે ફાઇન્ડ કરવાનું, ધેટ ઇઝ પાર્ટ ઓફ યોર સેકન્ડ ચેપ્ટર. એ તમારું કમ્પ્લીટ થઈ જશે પછી બાકીના જેટલા પણ અલ્ગોરિધમ આપણે ભણ્યા છે એ બધાનું એનાલિસિસ આપણે કરશું, રાઈટ? સો નો નીડ ટુ વરી અબાઉટ ધીસ કે આ કેવી રીતે આવ્યું, રાઈટ? સો કોમ્પ્લેક્સિટી ઓફ બાઇનરી સર્ચ ઇઝ થીટા log n. Right? Now this is the binary search example. Right? So example 1 and 2, right? You have to uh, take as an assignment. Right? So all of you write down this first and second example in your notebook, right? And submit this example in as an assignment 1. Right? I will upload the assignment 1 in assignment 1 questions on classroom, right? And there you have to submit your answer. Right? So અત્યારે નહીં લખશો તો ચાલશે, હું ક્લાસરૂમ પર મૂકી દઈશ આ બંને ક્વેશ્ચન. Right? So this is for your assignment 1. Okay. Now This is the first problem, right? The binary search, which you can solve with the use of divide and conquer method. Right? Now, second problem that we can solve using the divide and conquer strategy is multiplying the large integers. Right? Now, normally આપણે multiplication perform કરે છે, right? So we normally uh, familiar with the multiplication perform using positional numeral system. Right? જે આપણે સ્કૂલમાં શીખા છે multiplication of two numbers. Right? જે સ્કૂલમાં આપણે શીખા છે that is known as positional numeral numbers. Right? But in this method of multiplication, right, the multiplicand by each digit of multiplier and add up all the properly shifted results. Right? So this method is your positional numeral method or જે સ્કૂલમાં તમને multiplication કરાવતા હોય. Right? But this method is not convenient for performing the large integers. Right? આપણે large integer numbers નું multiplication કરવું હોય તો જે આપણી traditional multiplication method છે that is not convenient. Right? For that we require some special calculation or some special method. Right? That we can perform with the use of divide and conquer technique. Right? So divide and conquer technique also useful to solve the large multiplication of large integer numbers. Right? So how it will work? Right? So consider that we have to multiply 981 by 1234. Right? આપણે શું કરવું છે? We have to perform the multiplication of 981 by 1234. Right? So this is the two large numbers. Right? So first step to perform multiplication using divide and conquer method, right, is convert both the numbers into same length. Right? And split each operand in two parts. So here divide થઈ ગયું because we split each number into two parts. Right? So first step of divide and conquer method. Right? So first convert both the numbers into same length. Right? So 981 becomes 0981. Right? And 1234. Right? Then divide or split each operand into two parts. So 0981 becomes 0981 and 1234 become 12 and 34. Right? So W is equals to 09 and X is equals to 81 and Y is equals to 12 and Z is equals to 34. Right? Now we can write 0981 is equals to 10 square W plus X. Right? 10 square W. So 10 square into 09. Right? That is 0900 plus X. Right? Getting how it comes? Right? And 1234 means 10 square Y. So 10 square into 12 plus 34. અહીં સુધી ખબર પડી બધાને?
Yes, ma'am.
ઓકે, ખાલી એકલા દર્શનને જ ખબર પડે છે, બાકી બધાને નથી સમજ પડતી? હેની ગાંધી. Are you there, Henny
Yes, ma'am.
Gandhi?
Yes, ma'am.
સમજ પડી અહીંયા સુધી? હા, so at least say yes or no, or at least write down yes or no in your chat box. Okay. So this is your second step, right? Now the required product can be computed as 0981 into 1234. આપણે કરવાનું છે, right? Is equals to 10 square W plus X, right? Into this 10 square y plus z. રાઈટ. હવે આપણું સિમ્પલ મેથેમેટિક્સમાં જે ઇક્વેશન્સને આપણે સિમ્પ્લિફાઈડ કરીએ છીએ એ રીતે, સો 10 square w into 10 square y, that will become 10 raised to 4 w into y plus 10 square w into z plus x into 10 square y plus x into z. Right? Just આ બે equation simplify કરીએ છે. Right? And put all the value of w, y, x and z in this equation. Right? So we'll get the final answer like this. Right? તમારી પાસે નોટ અને પેન છે? રાઈટ. હવેથી એડીએ ના each and every lectureમાં રાઈટ નોટબુક, પેન એન્ડ કેલ્ક્યુલેટર એટલું લઈને બેસજો. રાઈટ. આઈડીએના દરેક લેક્ચરમાં નોટબુક, પેન અને કેલ્ક્યુલેટર એટલું લઈને બેસજો. સો if it is not there today, then it is okay. From next lecture, right? બધા પાસે જોઈશે મને. Okay. So if we calculate these numbers, you will get the answer this. Right? Now, above procedure still needs 4 half size multiplication, that is w into y, w into z, x into y, and x into z. Right? So, w into z plus x into y, that can be done as like this. R is equals to w plus x into y plus z, right, is equals to w into y plus w into z plus x into y plus x into z. Right? So હજી પણ આમાં multiplication જોઈએ છે તમને. So we can sorry. Okay. Right? So અહીંયા હજી પણ multiplication તમારા વધી જાય છે. Right? So we can simplify this multiplication. Right? Here we require 2 multiplication. Right? So if we do like this, r is equals to w plus x into y plus z. So instead of 2 multiplication, right, we require only 1 multiplication. So this is your initial equation, right? So now we can compute the required product as follow, that w into y, that will become the p. Put wy value into this, put xy value into this equation, and put xy wz value into this equation, right, and find out the value of r. Right? So here w into y is equals to p, x into y is equals to q, and w into z plus x into y as it is. So we get the equation like this, 10 raised to 4 into p, right? Put this value p, q and r value into this equation, initial equation, right? 10 raised to 4 p plus 10 raised to 2 r minus p minus q, because w into z plus x into y will become the p minus q minus r minus p minus q plus q, right? Put all the value of p, q and r in this equation, right, and you will get the answer. So this answer is same as the previous method answer, right? Previous જે આપણે multiplication કરેલું, this one, જેમાં આપણે કેટલા multiplication જોઈતા હતા? 4 multiplication, right? એમાં જે આન્સર આવતો હતો એ સેમ આન્સર આપણને આ રીતે આવશે. If we divide the problem into number of sub problems, right? So we can reduce the multiplication procedure, right, and get the final answer. Yeah, here we reduce the multiplication and we require only one multiplication procedure in this equation, right, and getting the same answer for that two large numbers, right? So this is the analysis of multiplication of large numbers, right? So 981 into 1234 can be reduced to three multiplication of two figure numbers, 09 into 12 and 81 into 34 and 90 into 46, together with a certain number of shifts, addition and subtraction, right? Now જેટલા multiplication ઓછા હશે એટલો computing time ઓછો થશે, right? So we can obtain an algorithm that can multiply two and figure numbers in a time. So that is Tn is equals to 3t n divided by 2 plus Gn. Right? Now solve this equation using the master theorem. So A is equals to 3, B is equals to 2 and Fn is equals to Gn. Right? So we get the time complexity n log 3 where n is a power of 2. Right? This is the second example for multiplying two large numbers 8114 and 7622. Right? So first step using divide and conquer is divide all the numbers into sub problems. Right? So 8114 will divide into two parts, w is equals to 81 and x is equals to 14. And 7622 will be divided into two parts, y is equals to 76 and z is equals to 22. Right? Then step number 2 is calculate p, q and r value, where p is equals to w into y, q is equals to x into z, r is equals to w plus x into y plus z. Right? And put this value into equation 10 raised to 4 p plus 10 raised to 2 r minus p minus q plus q. Right? So we'll get the multiplication answer. Right? So here you divide the problem into number of sub problems, right? Then solve the sub problems, right? Then combine the solution of sub problems and get the final solution as a whole. Right? So in this way, divide and conquer strategy is used to multiplying the large numbers. Getting?
Yes, ma'am.
Okay. So we stop here. Right? Next topic is merge sort. Merge sort is also one type of problem which we can solve using the divide and conquer strategy. Right? Now, as your previous semester, right, we are now taking your feedback